Now we can learn clearly about the first unit, digital system and binary number. So here in this video it's mostly about the binary numbers, octal number and the conversion of them. Okay, so please listen carefully. It will be very easy for sure. Okay, so here this is unit 1 of DLD. Okay, so now first let's discuss about digital system or the number system. Digital system or number system. As you are aware of this number system, I hope you are aware, right? It is with the 10 digits. Okay, this is the basic digital system with its 10 digits. The 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the 10 digits that we have in the number system. Okay. Now we have this as number system, right? Now in digital communication operates with binary numbers. Okay, this is about number system, but in the gates we are talking about zeros and ones. So zeros and ones will be like the binaries numbers. So these are called binary numbers, that is zeros and one, and the way we operate and do operations and all this comes under binary system, which is another new concept for you. Okay, so now let's discuss about the number of systems we have. So actually this number system is divided into 4 types. Okay, so let me discuss this 4 types and I'll tell you this 4 types and we'll discuss each one individually. Okay, so the first type of the system is binary system, and the next type is octal. Then we have decimal system, and then we have hexadecimal system. Okay, so these are the 4 types of systems in number systems. Okay, so remember this. Now we will discuss each thing in a specific way. Now let's go ahead and discuss about binary number system. So I told bi, so bi means 2. Okay, so bi means 2 and it has 0 and 1 as its representation. 0 and 1. Now the binary system are used in the digits of only zeros and ones, and now the binary position values as a power of 2. Remember the power of 2. Using this power of 2 representation we can represent this binary number system. Okay, and I hope everything to the power 0 is 1, right? And 2 to the power of 1 is 2. 2 to the power of 2 is how much? 4. 2 to the power of 3 is 8. Similarly, we have 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3 and so on. Okay, and here this is considered as a bit, remember, and this bit is called most significant bit, that is MSB. Okay, most significant bit. This is one type of representation, and here this is MSB, which are in positive powers. This is most significant bit. Okay, most significant bit, and the next one is LSB, which is least significant bit. Okay, so this is about LSB and MSB. Now let's take one quick example and let's represent this in the power of 2 so that you will be understanding it a more easier way. Okay, so let me take one simple number Okay, let me take this number and I am going to represent this in the power of 2. Okay, as we have discussed about MSB and LSB concept, let me write that. Okay, so first let me write that so that it will be easy for you to understand. So first we are having from positive to negative, remember that. Okay, so here we have point 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3. Now I hope you got a clear idea why we are writing dot. So obviously for decimals we will have points right here. So in point, for the point, left side is all about the positives and right side is all about the powers, that is negative powers. Okay, so remember like that. And now let's put these values here. Okay, it's 1101.101. Okay, so it's better for you to write this. First write this and then according to that arrange two powers. Okay, so that is how you are going to do. Now I am solving this clearly so that I will get in the form of decimals. Okay, so to get in the form of decimals I am trying to solve this. That is, let me start with this first one. Okay, so the first one here is 1 into 2 power 3. I am adding it 1 into 2 power 2. Sorry, here it is 2 power 2. It's not 2 power 3. Let me change this. Okay, so next we will go ahead and write the further numbers. That is 0 into 2 power 1 plus 1 into 2 power 0. Here we have point, remember, but we are not considering it at present. Okay, and then 1 into 2 to the power of minus 1, which can be written as 1 by 2, plus 0 into 1 by 2 power 2 plus 1 into 1 by 2 power 3. So if you solve this, like 8 plus 4 plus 2 power 1 is 2, but it is multiplied with 0, obviously 0. So here you will get answer, like let me write here, it is 8, 2 power 2 4, 0, 2 power 0 is 1, so 1 into 1 1, 1 by 2, 0 here, and 1 by 8. So once you solve this, let's take 1 by 2 as 0.5. 1 by 2 is 0.5. And what is 1 by 8? Any guess what is meant by 1? Like what is the value of 1 divided by 8? It is 0.125. Okay, so let's add all the things together. 8 plus 4, 12. 12 plus 1, 13. Point, here we have 0.5 and 0.125, that is 0.625. So this is the conversion from binary. Actually you can see this is in binary. By using power of 2 we have converted it into decimal. Okay, so this is about converting the binary to decimal format. Got it? Let's take another quick example so that you will be much more clear. But now you are the person to do it. Okay, let me give another one small example where I am going to write the question first and we will solve. But before knowing the answer, just pause the video, do it by yourself. If you are having any doubt, go back to the video that we have solved for this, solve it, and now you can see this answer. Okay, so like that you can learn. Fine. In the meantime, I will write this format. You also parallelly do it, or else you can pause the video and continue to do it. Okay, anything is fine. So first divide like this. It will be very easy for you. If you have already done it, if you have paused and already done it, forward the video and check with the result, or else make it in fast forward so that you can get to know very clearly. Okay, so now we will go with this 0. Here it will be all powers with positive 2 power 2, 2 power 3, 2 power 4, 2 power 5 and 2 power 6. Did you get this? And then similarly with this representation also. So this is about it. Now we are going to solve. Here I am multiplying each 2 power 6. For easy calculation I am avoiding zeros because there is no point of considering them anymore, right? So I'll not consider this things which are in 0, and we can directly add. Bad luck, there are more ones than zeros, right? 2 power 3, 2 power 2, 2 power 0, 1 by 2, 1 by 2 power 3, 1 by 2 power 4 and 1 by 2 power 5. Okay, so 2 power 6 is 64, 8, 4, and let me check here clearly. It is 2 power 0, right? So we have 2 power 3, 2 power 2 and 2 power 0 is 1. So 1 into 1, obviously it will be 1, right? And here we have 0 0.5, 0 0.125 and 1 by 2 power 4. How much you will get? 16. 1 by 16. You will get 0 0.0625 plus 1 by 32. So that you will get 0 0.03125. So add up all these things, you will get the answer. So here is the answer for this question. I hope you are now confident in converting the binary to decimal. Okay, and we discussed till now about the binary number system. Now we will go ahead and learn about octal number system also and converting them into decimal. Okay, so now as we did it for binary, I said binary means 2. Similarly oct means how many? Any guesses? Let me write. We are having here octal number system. So coming to this octal number system, octal means 8. Okay, so oct means 8. So the things that we are going to take or consider here is, as it is 8, it starts from 0 and ends with 7. Got it? So this is about octal system. And here I forgot to mention the base. Here the base is 2. Okay, the base is 2. Okay, that's the reason we have taken every time base as 2 here, and the power is according to the position. Here the base is 8. Okay, let me write here itself that the base is 8. Remember this. Now how this representation goes, dot to the left hand side, whatever are there, it will go with, starts with 0 and positive things, and towards right side whatever you have, you will go with negative sign, right? Negative powers. So this is the representation, and obviously I hope you have remembered MSB and LSB. So the left side positive part is called MSB and the right side negative part is called LSB. That is least significant bit, MSB is most significant bit. Okay, so now let's have a look about changing this octal digit into the particular decimal one. Here I am taking very simple example so that you will get the clear idea. So let me take the octal number as we have octal numbers from 0 to 7. I am taking the octal number today is 567. Okay, in the power of 8. Okay, now you have to find the decimal equivalent. You have to find the decimal equivalent. Okay, so now I'm going to write here everything is positive, there is no dot. So first write 5, 6, 7 and make it a box for further understanding. And now how we are going to write the power is from here 8 power 0, 8 power 1 and 8 power 2. Let me compute. 5 into 8 square, that is 64, plus 6 into 8 and 7 into anything power 0 is 1, right? So 5 into 64 plus 6 8s are 48 plus 7. So compute and you will get the answer around 375. And here don't forget to put the base 10. Here the base is 10. Here the base is 8. Okay, so this is how you convert from octal to decimal. Now we can go a bit advanced. That is, let me take another example for you. That is 4271.635 whole to the power 8. Sorry, whole to the base 8. Sorry. So it is here base 8. Now let me write this. If you want to try, pause the video and give it a try and then check with your answer parallelly. If not, listen and take some random numbers and do the practice. And moreover, I'm saying you practice is the main thing. Listening to the class and do practice, for sure you will get good marks. Okay, so let me represent here 8 power 0. It starts with 8 power 0 from left, and then here it starts with negative power, right? So this is how it goes. Let me compute. It is like 8 power 3, so 4 into 8 power 3 plus 2 into 8 square plus 7 into 8 plus 1. 8, anything power 1 is 1, plus 6 by 8 plus 3 by 8 square plus 5 by 8 cube. So solve this. It will get the answer around, you tell me how much will I get. That is, let me mark this here, and here you write the answer and don't forget to place the base 10 because we are converting from octal to decimal. Okay, so now without any further delay we will move on to the decimal number system. Okay, so the next one, already we have discussed about two types of number system and this is the third type of number system. I hope you are very much well aware of this decimal number system, but let me give you a quick idea. Okay, so in decimal numbers we can express any decimal number in the form of units, tens, hundreds, thousands and so on. Okay, so this is how you represent, and here the decimal numbers are from 0 to 9. Deci means 10, so here you will have the base as 10. Got it? And now I hope now itself you got the idea. You will represent with the power of tens, right? This is MSB bits, and here obviously the power is negative, and this is how you represent LSB. And as we are talking it as a form of bits, it should be in that format for easier understanding. I hope till now everything is clear. Now let's take a quick example and let's do the concept. Okay, it is a very silly concept. It's like proving whether it is correct or not. Okay, let me take a very simple example. That is 1234.56. okay, I'm writing 1234.56 and I am writing the 10 powers. Okay, so now have to do this. 10 power 0 10 power 1, 10 power 2, 10 power 3, 10 power minus 1, 10 power minus 2, right? So now 1 into 10 to the power of 3, 10,000, 200, 30 and 4, because 10 to the power of 1 is 1, 10 to the power of 0 is 1, and then 0.5 and 0.06. So this is how you go. So obviously the answer will be like 1234.56. Got it? So this is the representation of decimal number system. Got it? Next, the last system that we are going to discuss here in this class is hexadecimal system. So any idea about hexadecimal number system? So coming to this hexadecimal number system, here the base is 16. So in the meantime, I hope you would have guessed from where to where. Are you thinking like 0 to 15? Then you're wrong. It starts with 0, obviously. It starts with like this, 5, 6, 7, 8, 9. Till now everything is fine, well and good. But here the real thing comes. From 10, you start comparing with the alphabets. Like A represents 10 and B represents 11, C represents 12, 10, 11, 12, 13, 14 and 15. A, B, C, D, E, F, 10, 11, 12, 13, 14, 15. So this is the representation of like the numbers limit for a hexadecimal number system. Please make a note of this. Okay, so obviously here the base is 16. So before point you will have 16 power 0, 16 power 1, 16 power 2, so on. And towards here you will have 16 power minus 1, 16 power minus 2 and so on, right? So this is how it goes. And let me take a quick example and then we will move on to the next concept. Here I am taking 3 FD. Remember, FD are the part of hexadecimal, and here there is no point, so we'll start doing it from here itself. And I told you what is meant by F, what is meant by D. If you're further confused, do one thing, write this, or let me go back and check what is F and what is D. Okay, I'm writing here. It is 10, 11, 12, 13, 14 and 15. Okay, so we have here 3 into 16 square plus F. What is the value of F? 15. 15 into 16 power 1 plus D. What is the value of D? It is 13. So 13 into 16 power 0. Okay, so now let's do 3 into 256 plus 15 into 16 plus 13 into 1, because anything to the power of 0 is 1. So obviously by the end you will get the answer of 1021. Remember, we have changed this, so it will be decimals. We are changing from hexa to deci. Remember that. Okay, so this is about binary, decimal, hexa and octal. Okay, and I'll also share you the table which will give you an exact clear idea about this. Let me go with this table. Okay, so first of all I am representing decimal, and then I am representing binary, and then octal, and then hexa decimal. Okay, so here what we are going to do is, please remember bi means 0 to 1, it is only 2. Octa means it is of 0 to 7. Hexa means it is from 0 to F, right? So let me write this. Here I am writing from 0, 1, 2, 3, 4, 5, 6. Okay, here so on you can continue till 15 to get a clear idea. Okay, so here I am taking 4 digits for your clear understanding. Here it is like 2 power 0, 2 power 1, 2 power 2, 2 power 3. Okay, so here this will be the representation. Okay, so here I will take, here you need to make sure that you are doing well. So in order not to confuse you, I'm writing here 2 power 0, 2 power 1, 2 power 2 and 2 power 3. Okay, so here we have 4, 2 power 2 is 4 and remaining all will be 0, and for 5 this should be there and the last should be there. So like this, for 6 it should have 4 and 2 for the easier calculation, right? So this is how it goes for binary. And let me go with octal also. For octal, we have here 0 as 0, 1 as 1, 2 as 2, 3 as 3, because till 7 we don't face any problem. Remember that. Okay, till 0 we do not face any problem. Similarly for hexa also, for till some point we do not face any problem. This is also, remember it. Okay, so now in the next page I'm writing from 7, and let me do once again. Here we are taking here decimal, then binary, then octal, and then hexadecimal. Okay, fine. So now I'm continuing from 7. Okay, so let me write 7, 8, 9, 10, 11, 12, 13. I don't want to make it much stress. I just want to explain clearly. Okay, that's the reason I have taken in a different way. Now let me write here once again without your confusion. 2 power 2, 2 power 3. Here it is of 8 powers, right? So 8 power 0, 8 power 1, 8 power 2. Okay, here it is. I think it's not much needed, but we'll just see this later. Okay, next, here for 7, how we can write 7? Here is 8, here is 4, and here is 6. So 0 multiply 4, 6 and 7. There you go with 7 in binary format. For 8, for 9, 10. 10 means 8 plus 2, right? 8 is this first place and the third place. 11, 3, 12, 4. 8 plus 4 is enough. 13, this and this. Okay, so if you're a bit confused, I'm asking you to check parallelly with this. You have to add all this, so you will get the number this. Like suppose let's take 0, 1, 1, 1. 1 means 2 power 0, that is 1, plus 2 plus 4. Got it? So that is how I'm writing. Now similarly for 7 it is no need, but from 8 this octal will start. So 8 stands here in the second place. So I'm making here 8 as like this. Okay. 9, that is 0. Anything power 0 is 1. So this is how we write 9. And coming to 10, how we can write 10? That is 1 and 2. Okay. And for here we'll write 13, 14, 15, and this is how it goes. Okay, so please remember from 8 you can directly make a note that from 10 it should start and go ahead. Similarly for hexa, there is no problem till 9, but from 10 you need to make sure that you are representing with A, B, C and D. Okay, so that is half, and we just still left with another two numbers, that is 14 and 15, and let me explain that also in a clear way. Okay, so here 14 means you have to get with all this 8 plus 2, 10 plus 4, 14. So 1, 1, 1, 0 will be the 14. For 15, all the 1 should be there, like 4 1 should be there. Coming to octal, 16 for 14, and for 15 decimal you will have the value as 17. For hexadecimal it will be like for 14 E, for 15 F. Okay, so that is all about binary, decimal, octal and hexadecimal. I hope you understood it, and then we will further in the next video we will further learn about the conversions of this.